Hello everyone and welcome. Let's just dive right into it. Today we are completely deconstructing Review Exercise 2 for the Cambridge IGCSE Additional Mathematics syllabus. Look, if you want to truly master the interplay between algebra, geometry, and logarithms, you are absolutely in the right place. We're going to break down this entire 52-mark exercise together and extract the core strategies you actually need to succeed. The core philosophy we use here is that success in additional math isn't just about blindingly crunching numbers or, memorizing isolated formulas. It's about recognizing mathematical patterns. Our goal today is to push way beyond simple calculations. We're going to uncover the big overarching mathematical themes that are hiding in plain sight across these 11 distinct questions. Because when you finally start seeing how a basic inequality relates directly to a physical graph or how a polynomial factorizes into visual intercepts, that is when you've truly mastered the subject. So, here's our roadmap for this session. 1. Equations and inequalities. 2. Visualizing mathematical graphs. 3. Polynomials and simultaneous equations. And 4. Exponential and logarithmic models.
Okay, starting with Section 1, Equations and Inequalities. This is all about mastering those crucial algebraic foundations. Listen, building a rock-solid algebraic toolkit is absolutely critical before we do anything else. Just look at the specific inequalities this exercise throws at you. You've got question 1b involving absolute values and question 3 dropping a quadratic inequality on us. Now, pay close attention to the examiner's command word here, solve. This means we have to find the specific range of values for x. And always look at the mark allocations, 4 marks and 3 marks respectively. That tells you exactly how much algebraic working you need to show on the page. You literally cannot just jump to the final answer and expect full credit.
Let's look closely at the logical progression required to conquer question 3. Step 1 is always to expand those brackets, which gives us 3x squared plus 6x minus 2 is less than or equal to x squared. Step 2, we rearrange everything to one side to form your standard quadratic format, bringing us to 2x squared plus 6x minus 2 is less than or equal to 0. From here, finding your critical values is straightforward, which then naturally dictates the correct inequality range. It's a perfect example of how a seemingly complex problem is really just a series of simple logical steps. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, moving into Section 2, Visualizing Mathematical Graphs. We are shifting from pure algebra into geometry.
This is where the numbers we were just manipulating turn into visual curves, and our command word completely shifts from solve to sketch. Question 9 is a fantastic example of this. We need to contrast these two distinctly different logarithmic functions. On the left, we've got y equals the natural log of negative x. On the right, y equals the negative natural log of x. Look at how the placement of that single negative sign completely alters the entire graph. On the left, the negative inside the parentheses reflects the standard natural log graph across the y-axis, so it only exists for negative values of x. But on the right side, having the negative sign outside reflects the curve across the x-axis. Getting your head around these transformations is an absolute game changer for sketching accurately.
So what exactly is the examiner actually looking for when they hit you with the word sketch? Remember, you aren't plotting every single point. First things first, sketch the general shape based on the equation's format. Is it a parabola, a cubic curve, a logarithmic sweep? Next, and please don't forget this because it's crucial, state the specific equations of any asymptotes. Finally, pinpoint the exact coordinates where the curves crash into the x and y axes. If you stick to this exact checklist, I promise you'll grab full marks on graphing questions like numbers 2, 4b, and 9.
Let's move to Section 3, Polynomials and Simultaneous Equations. We're navigating complex intersections now.
Okay, brace yourselves, because this is the heaviest algebraic section of the exercise. This is where multiple concepts totally collide. Question 4 presents this brilliant algebraic puzzle. If a heavy degree 4 polynomial, p of x equals x to the power of 4 minus 4x cubed minus x squared plus 4x, has a known factor of x minus 2, how do we completely deconstruct the whole thing into a product of its linear factors?
Here are the exact strategic steps you need to score those 3 marks. First, you divide the entire polynomial by that known factor, x minus 2, using either polynomial long division or synthetic division, whichever you prefer. Second, you take the cubic expression that's left over and factorize that. Finally, you just keep breaking that expression down until you are left with only linear components. And remember what we learned just a minute ago? This algebraic teardown isn't just busy work, it directly hands you the x-intercepts, helping you sketch the graph perfectly in part B of the question. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's see how this all builds into question 6, which is all about finding intersections. We've got equation 1, a straight line, y equals x plus k, and equation 2, a curve, y equals kx squared minus 5x plus 2. To find out where they meet, we simply equate them. But here's the catch. The question specifically asks for the set of values for k where they intersect at 2 distinct points. This requires a fundamental mathematical truth. Once you equate them and form your quadratic, you absolutely must apply the discriminant. Setting b squared minus 4ac to be strictly greater than 0 is literally the only way you're going to solve for k here.
And if you want a true test of your skills, just look at question 7. This is a massive, challenging 5-mark problem that forces you to take the simultaneous equation techniques we just talked about and mash them together with complex logarithmic rules. You've got to use the laws of logarithms to combine the terms, convert them into their exponential forms to strip away the logs entirely, and then use substitution to solve for x and y. It sounds like a lot, but honestly, it's a beautiful synthesis of all your different algebraic skills working together.
Finally, Section 4, Exponential and Logarithmic Models. This is where we apply the math to the real world.
$12,000. That is the exact starting value of a car when it rolls off the lot brand new. In question 8, the examiner gives us the model, v equals 12,000 times e to the power of negative 0.2t. Think about it. When time t equals 0, meaning the car is brand new, e to the power of 0 is just 1. That leaves us boldly with that initial $12,000 value.
Now, let's turn this depreciation model into a bit of a story. As time takes on, obviously the car loses value. Question 8, part 2 asks, exactly how much time does it take for the car's value to drop to 2/3 of its original price? So you aren't just solving for some random letter t anymore, you are actually figuring out exactly when a major asset loses a massive chunk of its worth. So let's walk through the exact mechanism of solving this exponential decay. Step 1, set your target value. 2/3 of 12,000 is 8,000. So 8,000 equals 12,000 times e to the negative 0.2t. Step 2, divide both sides by 12,000 to isolate that base, which quickly simplifies down to the fraction 2/3. Step 3 is the magic move, guys. Apply the natural logarithm, ln, to both sides. Why? Because the natural log is the ultimate tool for rescuing a variable that's trapped up in the exponent of base e. It completely cancels the e, pulling that negative 0.2t right down to the main line, which allows us to effortlessly solve for t.
Of course, true logarithmic mastery means getting comfortable with way more than just base e. As we round out this whole 52-mark exercise, questions 1, 10, and 11 are basically tapping us on the shoulder to remind us that we need to manipulate all kinds of different bases. Whether you're taking logs of both sides to solve 5 to the power of 2x equals 12, or you're wrestling with competing bases like 10 and 8 in question 10, or using your log laws to compress a giant expression into a single logarithm to base 5 in question 11, the underlying principles of manipulation stay exactly the same. And honestly, that brilliantly illustrates our final takeaway for today. Acing Review Exercise 2, and by extension, your entire Cambridge IGCSE Additional Mathematics exam, is never going to be about rote memorization. It is fundamentally about understanding how algebraic formulas and visual graphs are constantly talking to each other. A factor becomes an intercept. An inequality literally defines a shaded region on a graph. A logarithm undoes an exponent. So as you keep studying, you've got to ask yourself, are you just memorizing the steps, or are you actually seeing the whole mathematical story unfold? Keep looking for those connections. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.